Hey everybody, it's Greenwood again with another tutorial video. And in today's video, I'm going to show you the basics of the three basic right triangle trigonometric ratios and give you an idea how to write those and the foundation for that. So let's get into it. In the last video, we talked about labeling. And so here's the triangle I labeled last time, where A is my reference angle. I labeled my hypotenuse, my opposite, and my adjacent. So if you're not sure where that came from, go back to the last video about labeling right triangles. So we're going to talk about sine, cosine, and tangent. I spelled them all out for you. And then let me make sure I've got the browser thing I want. Okay. So there's our Decimal Scientific Calculator. Email me if you need that link. We'll come back to that here in a second. All right. So here's my triangle. And we're looking at sides we can compare. And so when I asked my class to do this, I said, well, what sides do you see that you can compare? So pause the video, take a second, and take some thinking there about those sides. Okay, so hopefully you took a chance to look at that. So I can compare any of these numbers. So I could compare 5 to 13. I could compare, I could compare 12 to 13. I could compare 5 to 12. I could compare 13 to 5. I could compare 13 to 12. I could also compare 12 to 5. So those are the different combinations of things I could compare. And not coincidentally, there are actually 6 trigonometric ratios. What trigonometry means measure of triangles. There's a special name for each one of these. Okay. In this video, we're really just going to focus on these first 3. So I'm going to erase these. And they have special names. They're called sine, cosine, and tangent. And on my scientific calculator, you'll see we've got the sine, cosine, and tangent. And so you've probably seen those before, but weren't sure what they did. So therefore, finding missing sides and angles in right triangles. So let's talk about that. So this 5/13, this one is called sine. And I'm actually going to type these out, I think. So sine, put angle A. Okay, so A is my reference angle, and so the sine of A has a specific value, okay? And if that A changes that angle, then the ratio changes. So it wouldn't be 5/13 if it was a different size angle. It might be bigger or smaller. The second one's called cosine of A. And the last one, the 5/12, make sure I got these right. Yeah. Is the tangent of A. So these are the 3 basic right triangle trigonometric ratios that we'll be working with. And so key things, so they each relate different sides. So sine is a comparison of 2 sides, cosine is a comparison of 2 different sides, and tangent is yet another comparison of 2 sides. So these different combinations give us different ratios here, all in reference to angle A. And we can use these tools to help find missing angles and missing sides. So let's talk about the basic format of these. So if I'm looking at the labels that we did in the last video, that helps me figure out the relationship for sine, cosine, and tangent for any reference angle, whether it's really, really small, like 1 degree, or like 89 degrees, really close to 90, okay? So I'm going to rewrite, so 5, that was my 5. In place of 5, I'm going to write my label, which was opposite. So sine is going to be opposite. And then the 13, that's the hypotenuse. So I'm going to rewrite that as hypotenuse. So the sine of angle A, or really any reference angle, is always the comparison of the opposite side to the hypotenuse. My phone's ringing in the background. We'll get to them later. The cosine of this angle, so 12 is my adjacent side. So I'm going to rewrite, instead of 12, I'm going to write adjacent. And 13, still my hypotenuse label. So we'll write in the hypotenuse here, HYP. And then lastly, tangent. So the opposite side is 5. So we'll write it opposite. So you can probably already see where this is going, the 12. I better scoot my video down just a little bit. There we go. And then the 12 you can see is the adjacent. And I used a lot of color here. And I think as you're doing things like Nearpod and you've got a lot of these digital tools, color is so good to help things stick in your mind. So I labeled all my opposite blue. I used red for my hypotenuse and green for my adjacent. You can use whatever colors you want. It doesn't really matter. But as long as you're color coding things, it can help you make sense and help your brain remember it, okay? So here we go. There is our set of 3 trigonometric ratios. So sine is always opposite over hypotenuse, cosine is always adjacent over hypotenuse, and tangent is always opposite over adjacent, okay? And so there is a fancy word here that will help us remember this, and that's called Sohcahtoa. Okay, so Sohcahtoa is a way to remember the order of these things. So sine is opposite over hypotenuse, and I'll use my colors again to kind of help you connect. So O is blue, H is red. Cosine is adjacent over hypotenuse. My adjacent was green. My hypotenuse is red, and then blue is opposite, and green is adjacent. So here's my sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So there's a way to remember, a mnemonic device. So we made up this funny word, Sohcahtoa, which helps us remember the order these ratios go in. Okay, so in the next video, we'll be talking about how to calculate a missing angle using our trigonometric info using these ratios. And then in a future video after that, we'll talk about how to find a missing side. I hope this one helped, and we'll see you in the next video. Bye.